Hello all, my name is Deepranjan. A very good morning to all of you. So today in this video I'm going to explain you another machine learning topic, that is support vector machine. Okay, so support vector machine is one of the most popular supervised learning algorithm which is used for classification as well as regression problem. Primarily we are using it for the classification problem in machine learning. So the goal of SVM algorithm is to draw a decision boundary, like draw a best fit line that can segregate n-dimensional space into classes so that we can easily put new data points in the correct categories in the future. And these decision boundaries, these best fit line are known as hyperplane. Okay, so let me explain you through like a diagram, this one. So if you can see here, this is a support vector machine, like a it's the internal working of a support vector machine we are going to see. So you can see here, these are the data points, this blue one and this green one. These are two classes, okay, which are separated from each other. So here you can see it is mentioned here, this one as a support vector and this one as a support vector. So why only this point is mentioned as a support vector? Why don't this one and this one is mentioned as a support vector? So there is a logic behind it, right? So the value, okay, so the distance between the opposite classes, whatever distance between the opposite classes, whichever point will be nearer to the opposite class will be known as support vector. Okay, so this point is closer to this point, right? And this one is closer, so this one is not closer to this one, right? So this one is closer, and this one is closer, so that's why this one is known as support vector. Okay, and we are going to draw a line here, this line and this line. These lines are called as margin also. Okay, so from this support vector we are going to draw this line, and that line will be parallel. Okay, they won't intersect each other. Okay, and in between that we are going to draw a one more line. That line is called as optimal hyperplane or a decision boundary. Why it is known as decision boundary? Because like after this line, like from this left side and the right side, if any points belongs to the left side of this line will belongs to blue class, and any points which lie in right side of this line, that will be considered as a green class. So this is our hyperplane, optimal hyperplane, or also known as decision boundary. So that's why it is known as support vector, because of using support vectors, it is drawing a hyperplane. Okay, and we already read here, like it is trying to create a best fit line. And how it is creating? With the help of this support vector, it is creating this line, this decision boundary or this hyperplane. Okay, and there may be different lines, right? Different, like we can draw it from here this way and this way also. So it will take only those it will consider those hyperplane as a optimal one, whichever having a maximum margin. Okay, so whichever having the maximum margin, that will be considered as the optimal hyperplane. Okay, so now come to some different things, right? Different point, like what are disadvantages of this concept? Okay, not disadvantage, there is some trick behind that. So like I have mentioned here, when the data is not linearly separable, then to create a hyperplane to separate data in different group, SVM algorithm needs to perform computation in higher dimensional space. Okay, so this one is higher dimensional. So if you can see this image, okay, so in this image we won't be able to draw a line, a hyperplane, right? Okay, if we go for a decision tree, then we can draw a zigzag kind of line, but for SVM uses here hyperplane only. Okay, so we can't draw it. So how we will deal with this kind of a data? So for that they are using a trick here. That trick is known as kernel trick. So inside that kernel trick they are using kernel functions. Okay, that is provided by the mathematicians. Okay, and inside that kernel function they are trying to calculate new coordinates, like a higher dimensional space. Let's suppose this point is on the axis, this, let's consider this one. So this point is in a two-dimensional space, x and y coordinate. Okay, right? So by using this kernel tricks, what we will do uh, will calculate a new coordinate, or make our data into a higher dimensional space by using these kernel tricks only. Okay, and what will be these kernel tricks? Kernel tricks are nothing, it's just a function, right? Any kind of a function you can write it to create a new to generate new coordinate. Okay, and here I have also mentioned here the unique feature of kernel function is to compute in a higher dimensional space without calculating the new coordinates in that higher dimension. It implicitly uses predefined mathematical functions to do operations, right? So just these are just mathematical functions, and these are known as kernel tricks. So what all kernel tricks are present in SVM, that we will discuss during the implementation part, that I'll show you. So coming to the implementation, so I have taken a data set here. That data set is wine quality detection. Okay, so it's a classification problem, multi-class classification problem, and you can see here it has like multiple classes. You can see here 5 also, but it has a multiple classes. If you want, I'll just run it. Okay, it is just loading the data. Here I'm just checking our null values. So there is no null values, then I'm doing a standardization here. Okay, so because of that there are a lot of values which are varying, like in this one you can see 11. I'll do here one more thing, that is df.describe. so it will help you to understand why I am doing here a standardization. So you can see here the values. Okay, so minimum values here is 4, minimum values here is 0 point something, and this one is 1, this one is 6, this one is, so like in every rows it is varying. Okay, so to keep it in a some scale, okay, we are using here standard scaling. Okay, so nothing else we are doing here, just checking the columns, and we are just creating one new data frame after the scaling. Okay, then we are just taking our independent and dependent column separately. We are doing just separating here. Then just train test split, calling SVC from SVM, because we are using here classification problem dually, so that's why we are using here SVC. Otherwise, if you go for a regression problem, then that case we are going to use SVR. So just load this model, then predict, and let's check the accuracy. Got 59%. Okay, so that is fine, and we are going to implement here some great search CV just to increase the accuracy. Let me run this. These are parameters that we are going to pass here, fit with the data. It will take couple of seconds, just wait for that. It's 24 task is done. I think 150 fits it will do. Okay, now it's done. We'll get the best parameters. So we got the best parameters, you can see. So now we got the accuracy of 62. Earlier we were getting a 59%. So that is the thing, nothing else. So I was talking about the kernels, right? Let's check what all kernels are present here. So you can see here there is a parameter called kernel, and by default it is using RBF, radial basis function. Okay, and let me tell you what all kernel tricks are available as of now. We can implement our own also, that's not an issue. So linear, polynomial, RBF, sigmoid, precomputer, these many kernels are present. You can check on Google what all functions. Like if I'll check for this RBF one, RBF kernel, let me check what is the functions they are using behind that. Let me check the Wikipedia page only. Okay, so you can see here this function they are using to keep our data into a higher dimensional space, okay, without calculating a new coordinate. Okay, so these things you can do, you can check for linear also. I can do that linear. Okay, this is a gigs for this. Let me open this gigs for gigs only. Okay, we need to just check what all functions they are using. Okay, I don't think so it is there. Okay, okay, leave it. I'll just leave it on you. You can use whatever kernels you want. Okay, polynomial kernels. Okay, so fine, this is end for this video. uh, Fine, bye bye.